Okay, so we're moving on to part two of the sums of squares the long way. So this is the data that we completed in the last video. So we got all the way through to our within subjects sum of squares. And just a reminder about what that is. Within subjects is how the scores within a group vary from one another. So our sum of squares here, which we're calling S over A, our sum of squares S over A, is looking at how the scores in the noise group vary from one another and how the scores in the no noise group vary from one another. In order to figure out how these groups compare to one another, we are going to calculate our between subjects sum of squares. All right, so the first thing that we're going to do here, we're going to do this very similar to how we did this. We're going to get a deviation and then we're going to square it. All right, so the formula for the deviation is y bar A minus y bar T. That's a little bit hard to see. I'm going to see if I can get a better ink color here. Is this one any better? It's not terribly better, but I'm going to try this color. All right, so y bar A minus y bar T. All right, so if you've got these columns labeled properly, you'll be able to see here's our y bar A and here's our y bar T. So what we're going to do is for this first row, we're going to take the y bar A, which is 1, and subtract the y bar T, which is 3.5. And that equals negative 2.5. Moving down to the next one, we have 1 minus 3.5, which is negative 2.5. This is not a trick. You can see each one of these scores in the first group. The y bar A is the same for each one of these, and the y bar T is the same. So once we calculate this once, we really have it for the whole column, or for the whole group at least. All right, moving down to the next group, it's going to be different. So the y bar A here is 6, and the y bar T is 3.5. So we've got 6 minus 3.5 is positive 2.5. And again, once we calculate it once, it's going to be the same for everybody in that group. So each one of these is going to be positive 2.5, which I have not lined these up very good. There's 5 of them. All right, so just like we did here, we are going to add up all the deviation scores for this column. All right, so the sum of these is going to be 0, and again, this is an important check for you to do. The sum of the deviations should always be 0. And we can eyeball this. These are negative 2.5s, positive 2.5s. This obviously adds up to 0. Now, some of you might be wondering, is it always going to look like this, where the deviation for one group is a mirror image of the deviation for another? Yes, when you have two groups, it's always going to look like this. You're going to have negative some number and positive the exact same number. Once you get 3 groups, it's going to be different. All right, so these are our deviations. The next step, some of you might be able to predict, the next step is we are going to square those deviations. So we've got y bar A minus y bar T squared, just like we did with the within subjects. So we're going to go through each one of these scores and square them. All right, so negative 2.5 squared is 6.25. And again, these are all the same. So once we have the one, we have them all. So 6.25, 6.25, 6.25. And 2.5 squared is also going to be 6.25, not 6.5, 6.25. I can't talk and write at the same time. 6.25, 6.25, 6.25. All right, so they're all the same number. Again, it's because there's only 2 groups. And just like we did with our within subjects, we're going to add these all up. So 6.25 10 times is 62.5. And just like over here, this is the sum of the squared deviations. So this is going to be a sum of squares. And the name for this is sum of squares A. And this is our between subjects sum of squares. So thinking about how I defined between subjects, this is looking at how the mean of this group compares to the mean of this group. All right, so just to review what we've done so far, and then we're going to do the last step of this. In red here, we did this in the previous video. This is looking at the within subjects sum of squares. And the formulas here should look really familiar because this is exactly what we did in the last section where we calculated variability for the first exam. So all we're doing is we're looking at how each score deviates from its group mean. This new stuff in blue, this is our between subjects business. This is our between subjects sum of squares. So we're looking at how each group mean compares to the grand mean. And just like we did with the within subjects, the first thing we do is get a deviation. The sum of the deviations should equal 0. And the next thing we do is we square it. Then we add them all up, and this is called a sum of squares. And the type of sum of squares it is the between subjects, and we label it sum of squares A. So our within subjects is S over A, and our between subjects is A. Again, if this seems totally muddy, totally abstract, don't worry. We are going to have plenty of opportunities to practice this. And I can tell you, once we do this long way, this very tedious long way, once we do this once, we're never going to do it again. I'm really just putting this up here to show you guys where these numbers come from. All right, so you might think that we're done because I told you there were 2 sources of variability, within and between. But we're going to put 2 more columns on here because we're going to look at the total variability as well. And we'll do that in the next video.